This simplified animation shows how uranium is extracted. This is the uranium ore, and it is extracted using a drill that pulls the reamer up through the pilot hole, widening it. The broken ore then falls into what is known as an extraction chamber. Next, a bulldozer, operated remotely to keep the operator at a safe distance from falling rock hazards, picks up the uranium rock. Fast forward, the uranium is then condensed, ground, and placed into a centrifuge for further enrichment. Everyone is talking about centrifuge enrichment, but let's explore how it actually works. In this visualization, the green dots represent uranium-238 atoms, while the blue dots represent the concentration of uranium-235 atoms. This first batch is natural uranium, which contains only 0.7% of uranium-235. Here, in this image, we have 5% low-enriched uranium, which is used for commercial nuclear power plants. Finally, we have weapons-grade uranium, which contains 90% uranium-235. As you can see, almost all the uranium-238 has been removed, and it is replaced by uranium-235 representing the color blue. Let's show how this is extracted through super simplified animation. The centrifuge consists of a high-grade tube with a spinning motor at the bottom and a feeding tube at the top. Uranium is fed into the centrifuge as a gas called uranium hexafluoride. As the motor spins at high speed, the heavier uranium-238 is separated from the lighter uranium-235 using centrifugal force. The uranium-235 floats to the top and is collected at this section of the centrifuge, while the heavier uranium-238 in the color green falls to the bottom of the centrifuge and the enrichment process is complete. To understand how nuclear bombs are made, let's analyze how Little Boy and Fat Man works in super simplified animations. This is the Fat Man atomic bomb is a large, heavy plutonium imploded using shaped charges as shown in the animations. While Little Boy has a less heavy uranium weapons triggered in a shotgun or gun-type designs. The Little Boy has a length of 10 feet or 3 meters with a diameter of 28 inches 71 centimeters. While the Fat Man has a length of 10 feet or 3.3 meters, but a much larger diameter of 60 inches or 1.5 meters. Comparing this to a person will help you understand its size. Oppenheimer Trinity test marked the inception of the implosion-designed plutonium, eventually leading to the detonation of the Fat Man atomic weapon. The outer charge explodes inward, followed by the inner ring of explosives, creating a concave shockwave. It moves this pusher here, breaking the barren plastic sphere. The shockwaves continue toward the uranium-238. It travels further, compressing the plutonium sphere and compressing it more. Interestingly, this was James Tuck's idea, a British physicist who suggested employing shaped charges as three-dimensional explosive lenses, but it was further developed and perfected by von Neumann, a Hungarian-American mathematician, physicist, and computer scientist.